All right. So what exactly is a bipolar junction transistor? So a transistor basically is a three-terminal device. What we have seen so far, the PN junction diode was essentially a two-terminal device. So this is a three-terminal device. And this transistor, this particular word has been coined by a combination of two, let us say, words, that is transfer of resistor. Now this may sound a little bit confusing, but we'll see how it really correlates to our device. So bipolar device means that basically why is it called as bipolar? That is also what you have to understand. So why bipolar? Because it is making use of both type of both type of charge carriers. What are the types of charge carriers? What are the charge carriers in semiconductors?
Sir, holes and free
Elect
electrons.
Okay, holes and electrons. So holes and electrons both play a role in this particular transistor, and that is the reason why it is called as bipolar. Essentially, we consider holes as positive and electrons as negative roughly. So that is the reason why we call it as bipolar transistor. Why junction? Because it will be made up of, the transistor will be made up of junctions. Okay, so we have these transistors operate with both type of carrier, charge carriers. Okay. Now there are transistors which operate with only one type of charge carriers. Okay. We'll see that in the unit number 4, and they are called as field effect transistors. Just for your information. All right. So bipolar junction transistor has got two PN junctions. Okay. So we have two PN junctions. Okay. And we have already said that it is a three-terminal device. So there are three sets of current voltage characteristics. This is very important. So we have three sets of VI characteristics. Initially, when we talked about the PN junction diode, it was a simple VI characteristic because there was only one junction. So we had something like this. Okay, VI characteristics. So in this case, we have three sets of VI characteristics. We are going to see why we call it, why do we have three sets of characteristics. First, please remember this first of all. And they are defined, and the performance may be defined based on these characteristics. Now the transistor can perform one very important function of what is called as amplification or current amplification, to be more precise here. So we have current amplification. This amplification, we can also have voltage amplification. So a junction transistor is simply a sandwich of one type of semiconductor, that is either P type or N type, between two layers of other types. So if I show you the picture of what exactly you have, let me just copy the picture from my Visio file, and then things will be clear to you. So is this picture visible to all?
Yes, sir.
So look at the construction. We have two different conductor which is sandwiched between two other types of semiconductors. Now we have two types of conductors, N-type semiconductors, N-type and P-type. So here you can see that the P-type is sandwiched between two N-type semiconductor material. Okay, and obviously what we have here is a junction. So as you can see here, this particular junction is nothing but this is one junction and this is another junction. That is how we get two different types of junctions. Is that clear to all of you? First of all, understand the geometry of the device. In a similar way, we can have another type of transistor where we have N-type semiconductor sandwiched between two P-type semiconductors. Okay, and again we have two junctions. Okay, now the transistor terminals are marked in a very specific way. You can see here that this terminal, okay, is called as a collector. So this is called as a collector. This is called as base, and this is called as emitter. Okay, this terminal. Similar cases with this transistor. Okay, is the geometry clear to all of you, guys?
Yes.
Hello.
Sir.
Please respond. Yes, otherwise, I feel that there is no network connection, and so there won't be any feedback here. So please respond promptly. Okay, so geometry is clear to all of you. Right. Now let us look at the symbols. The symbols that are used for describing this transistor. This is one type of symbol. This is another type of symbol. What do you see the difference? What is the difference between these two symbols? Are they same?
No, sir.
They are not. What is the difference, by the way? Spot the difference.
Sir, the orientation of the arrow.
Yes. Let us say the direction of the arrow is different in these two cases, and there is a reason why it is shown like this. So basically, this is called as a NPN device or NPN transistor. Why is it called as NPN transistor? Because we have this N, we have this P, and we have this N types of semiconductors arranged in this particular way. Okay. Similarly, this will be called as a PNP transistor. Now, this arrowhead is very interesting. This arrowhead actually indicates the direction. Let's say the arrowhead indicates.
So,
yes.
Sir, are you writing something?
Is it not visible?
No, sir, I'm not able to see it. My screen is freezed.
What about
the other? No, sir, I am not able to see it.
Then you should have told me, na? Let me check. Let me reshare the content so that. Okay, it's better if we share this now. Okay, now?
Yes, sir. Now it is visible.
Okay, so arrowhead indicates the direction of conventional current flow. Very, very important. So what does the arrow indicate? It indicates. So how will the current flow? It will flow like this. In this case, the current is going to flow like this. Understand this first. Is it visible now properly?
Yes, sir.
Okay. So these two PN junctions exist within the transistor. These two junctions, we are going to call them as collector base junction, and we are going to call the other as emitter base junction. These are very important terminologies. So we are going to call this as the collector base junction. We are going to call this as emitter emitter base junction. Similar is the case over here. All right.
Yes, sir.
Is that fine?
Yes, sir.
So once you have the junction, what is the picture that emerges? Just let me get that picture over here. What is the picture that emerges is something like this. Are you able to see the figure?
Yes, sir.
Okay, this is for the NPN, right?
Excuse me, sir.
Similarly,
Actually,
yes.
the markings of the diagram are being cropped.
Let me see what. Okay, are the figures clear, visible to all of you?
Yes, sir.
Yes.
So we have this kind of picture, just like the PN junction diode. We have this kind of picture. What is it? What does it show you basically? It shows you this is the junction. These two are the junctions. The red one is the emitter base junction. The blue one is the base collector base junction. Similar is the let us say color coding which is being used by me here. Okay. Now interesting thing is that the semiconductor materials are not equally doped. Please remember one thing. Okay. So I'll write here one more thing. Junction semiconductor material is not equally doped. What do you mean by unequally doped or not equally doped? What do you mean by that?
Sir,
The amount
ppm
of
Yes, impurity atoms, if they are less, then you call it as lightly doped. If the impurity atoms are more, you call it as heavily doped. Okay, na? And remember one thing that whenever we have light doping, means the number of yes, hello, क्या हो रहा है? Number of charge carriers is less. Similarly, Hello, am I audible?
Yes, sir.
I know there was call drop. Let me reshare the content. I don't know what's wrong with this. Okay, so I was saying that if you have light doping, you have number of charge carriers less. If you have heavy doping, the number of charge carriers is more. Okay, just keep this in mind. So, generally speaking, what we have here is the base is lightly doped. And the emitter and collectors are heavily doped. Now this gives rise to one condition. What is that condition? If you have unequal doping, what will happen to the depletion region penetration? Guys, please respond.
Sir, it will shift towards who
The
has light.
depletion region, yes, the depletion region extends more into the lightly doped regions. Please remember this. So depletion region in this case will penetrate deeper into the base. You see this phenomenon over here. What is it showing? It shows that you have the base. You can see here the boundary. So the depletion region extends more into the base rather than over here. So emitter region में depletion region कम है और base में depletion region का penetration ज़्यादा है. समझ में आया? Have all of you understood this?
Yes, sir.
So it's the same case with PNP type. All right. And correspondingly, if you see the barrier voltages, the other day we were talking about barrier potential, barrier voltages, and we have something like this over here. So what do you see here essentially is that the barrier potential is something like this. When we are not connected any external voltage across the device. Okay? यहाँ तक ठीक है?
Yes, sir.
Okay. Next point is we'll be directly going to see the NPN transistor now. So that will actually start with the how NPN transistor really works. Okay. Another important thing that you have to understand here is that the fact that I am going to do one thing, I am going to apply an external voltage now. So let me just get this figure. Okay, is the figure visible to all?
Yes, sir.
So what we
Yes,
are doing
sir.
here is one important thing. We are going to forward bias the emitter base junction, and we are going to reverse bias the collector base junction. इसका मतलब क्या हुआ? अच्छा, फॉरवर्ड बायस एंड रिवर्स बायस कैसे याद रखना है गाइस? फॉरवर्ड बायस रिवर्स बायस कैसे याद रखना है?
Sir, according to which terminal is connected to.
So N, P, I'm not showing any depletion region here. तो n को अगर मैं नेगेटिव देता हूं और p को पॉजिटिव देता हूं तो ये हो गया फॉरवर्ड बायस। याद रखो। सो n समझो ये नेगेटिव है, ऑलराइट। आई एम कनेक्टिंग नेगेटिव टू नेगेटिव, पॉजिटिव टू पॉजिटिव। ये हो गया फॉरवर्ड बायस। रिवर्स बायस कैसे होगा? नेगेटिव टू
And
पॉजिटिव,
positive.
नेगेटिव। ये हो गया रिवर्स बायस। ये याद रखो बस, दैट्स ऑल, यू विल नेवर हैव एनी प्रॉब्लम। और एक बात, whenever I forward bias a PN junction, what will happen to the voltage barrier or the barrier potential?
Sir, it will decrease.
Yes, the barrier potential decreases. So if I write down over here, forward bias reduces barrier potential. Reverse bias increases barrier potential.
Potential.
समझ में आया? Now
Yes,
in
sir.
this situation, what we are doing is we are playing a very simple trick, and that is we are forward biasing the emitter base junction or base emitter junction and reverse biasing the collector base junction. तो इससे क्या होने वाला है? इससे क्या होने वाला है? इससे क्या होने वाला है? As you can see here, the barrier potential for emitter base junction is reduced, whereas barrier potential for collector base junction has increased. समझ में आ रहा है कि नहीं?
Yes, sir. Yes, sir.
Simple, very simple steps. So once I forward bias the emitter base junction and reverse bias the collector base junction, these changes will happen. Okay, so उससे क्या होगा? फॉरवर्ड बायस हो गया जंक्शन, फॉरवर्ड बायस कर दिया मैंने, तो फॉरवर्ड बायस करने के बाद क्या होता है पीएन जंक्शन में? द करंट विल स्टार्ट फ्लोइंग, नो? यस और नो?
Yes, sir.
कैसे फ्लो होगा करंट? समझो दिस, यहाँ पे एन टाइप मटेरियल है, तो यू हैव लार्ज नंबर ऑफ इलेक्ट्रॉन्स, इजंट इट? यू हैव लार्ज नंबर ऑफ इलेक्ट्रॉन्स हियर, है ना? है कि नहीं है?
Yes, sir.
So these electrons will get repelled by this negative potential of the battery and they will cross over into the base region. ये सब यह base region में चले जाएंगे. चार्ज कैरियर्स और मेजॉरिटी चार्ज कैरियर्स के बारे में देखना, सोचना है. See that who are majority charge carriers in this region? ये रीजन में मेजॉरिटी चार्ज कैरियर्स कौन है? इलेक्ट्रॉन्स है या होल्स है?
Electrons.
इलेक्ट्रॉन्स है मेजॉरिटी. ये पी टाइप रीजन है, तो यहाँ पे मेजॉरिटी चार्ज कैरियर्स कौन है?
Holes.
Holes.
पी टाइप में मेजॉरिटी चार्ज कैरियर्स आर होल्स. लेकिन अनइक्वल डोपिंग है, याद रखो. बेस लाइटली डोप्ड है, तो नंबर ऑफ चार्ज कैरियर्स इन पी टाइप इज लेस, whereas number of charge carriers in n type are more, है ना? तो फॉरवर्ड and that is I will repeat it here, that forward bias aids the flow of majority charge carriers. And we have a corollary to this. What is that? Reverse bias aids the flow of what?
Some minority charge carrier.
Minority charge carriers. याद है अब PN junction diode में when it was reverse bias, a small current was flowing. Still, we called it as the reverse saturation current. Do you remember that?
Yes, sir.
Okay, so this actually will form the basis of understanding of the transistor. Remember this very properly. Okay, so electrons which are in majority, they cross over into base. ठीक है ना? There will be some minority carriers also. I'll mark it as plus now. Doesn't matter here. Okay, there are very few, and they will cross over here like this. This may be because of some temperature effects and so on and so forth. ठीक है ना? There will be small current corresponding to the minority charge carriers or majority charge carriers from base coming into the emitter. Acha. Okay, so I'll just simplify this. अभी इसके बारे में नहीं सोचते. Okay. All right. Now this majority charge carriers come over here in the p-type base. अभी देखो p-type base में ये क्या है, मेजॉरिटी चार्ज कैरियर से या माइनॉरिटी चार्ज कैरियर से? ये जो इलेक्ट्रॉन्स यहाँ पे आ रहे हैं, the electrons which are migrating into the p-type base, are they majority charge carriers or minority charge carriers in p-type region?
Sir, minority charge carrier.
ये माइनॉरिटी बन गए वो, यानी माइनॉरिटी बन गई है. They are minority charge carriers. Okay, so we have a lot of minority charge carriers in this p-type because this is the p-type region. Minority does not mean that they are less in number here. Number तो बहुत ज्यादा है. ये these electrons they come here and they become minority charge carriers over here, but they are large in number. So technically they are not major, they are not minority, they are not in minority, but doesn't matter. We call them as minority charge carriers because p-type में electrons essentially are minority charge carriers. Okay, so ये यहाँ पे आते हैं, तो यहाँ पे आके ये इलेक्ट्रॉन्स को क्या दिखाई देता है? ये दिखाई देता है ना, ये जंक्शन और एक जंक्शन दिखाई देता है ना?
Yes, sir.
Yes, sir.
So what is that junction? It's the collector base junction, right? और collector base junction क्या है? Forward bias है या reverse bias है?
Sir, reverse bias.
Reverse bias.
Reverse bias.
So, reverse bias क्या करेगा उसको? When these electrons come into the base, become minority charge carriers, they see a reverse bias. यहाँ तक ठीक है?
Yes, sir.
Yes.
And we already have said, established the fact that reverse bias will help the flow of minority charge carriers. तो क्या होगा? ये electrons, they will further go into the collector region very happily. Why? Why will they go into the collector region? Why will these electrons go into the collector region? Guys? Hello?
Because reverse bias aids the flow of minority charge carriers. That's
Excellent, excellent, excellent. I'm just trying to see whether you have understood the phenomena and the concept. So that is how the electrons start from here. They are emitted by the emitter and they are collected into the collector. ये समझ में आ गया?
Yes.
This is very, very important. So electrons are collected in the collector because of this phenomenon. ये बात ध्यान में रखना. Now there will be some. See that here you have holes, you have electrons, right? And these holes, these electrons are coming over here, and it is quite possible that some electron holes may recombine. So recombine हो गया तो not all electrons will be collected in the collector. Not all electrons emitted by the emitter will land up in collector. Okay? So समझो 100 electrons emit हो गए तो उसमें से 95 electrons ही सिर्फ collector में आ पाएंगे. बाकी 5 इलेक्ट्रॉन जो है वो बेस के होल्स के साथ रिकम्बाइन हो जाएंगे. ठीक है? समझ में आया?
Yes, sir.
This is the transistor action. Please remember this. It may seem easy now. Guys, am I audible?
Yes, sir.
Yes, sir.
Okay, so is this working of this thing clear to all of you? If there are any questions, please ask me because this is a very important concept. You see that the concepts are the devices, the working of the devices will be understood once you understand the concept, and the concepts are underlying. No, they are dependent on the underlying still further concepts. So that is the reason why I'm telling you. Please write down the concepts as and when you come across them. So you'll get a nice collection of concepts. Okay?
Yes, sir.
Okay. In a similar way, what will happen to PNP device? Let me see whether I have that picture. If not, we can just extrapolate. तो अगर PNP डिवाइस है and if I have to draw it here, may not have on this anyways. So यहाँ पे अभी P है, यहाँ पे N है, यहाँ पे P है. तो इसको मैं फॉरवर्ड बायस करना है मुझे. तो हाउ शुड आई अप्लाई द वोल्टेजेस? ये हो गया एमिटर, ये हो गया बेस और ये हो गया कलेक्टर. हाउ शुड आई अप्लाई द फॉरवर्ड बायस टू PN जंक्शन एंड रिवर्स बायस टू बेस कलेक्टर बेस जंक्शन? एमिटर बेस जंक्शन है ना, उसको मुझे फॉरवर्ड बायस करना है. तो क्या करना है, कैसे लगाऊं? हाउ शुड आई अप्लाई द बैटरी? टेल मी guys. Hello, am I audible? Guys, am I audible?
Yes, sir.
Then
Yes, sir.
respond ना. मुझे समझ में नहीं आता है, कॉल ड्रॉप हो गया, क्या हो गया मुझे पता नहीं चलता है. तो you have to respond at least yes or no. Okay, so how do I connect it? यहाँ पे मुझे कनेक्ट करना है ना, कैसे कनेक्ट करना है? How should be the battery connected? How should the battery be connected? Come on, tell me.
Sir, left side
इसको पॉजिटिव और यहाँ पे क्या करना है, यहाँ पे पॉजिटिव। तो अब क्या होगा, हु आर इन मेजॉरिटी कैरियर्स क्या है पी टाइप में? पी टाइप में मेजॉरिटी कैरियर्स कौन है, इलेक्ट्रॉन से या होल से? गाइस हेलो,
होल से सर।
होल से, तो उसको मैं पॉजिटिव से मार्क करूंगा। और एन टाइप में मेजॉरिटी कौन है, इलेक्ट्रॉन से, लेकिन वो बहुत कम है ना?
यस सर।
यहाँ पे मेजॉरिटी कौन है, कलेक्टर में मेजॉरिटी कौन है? यस, अरे कौन सा टाइप का सेमीकंडक्टर है? हेलो,
सर PNP सेमीकंडक्टर।
पी टाइप है ना? तो
यस
यहाँ पे
सर।
मेजॉरिटी कौन है,
Holes.
होल से, ठीक है, उसको मार्क नहीं करेंगे, रहने दो। ठीक है, तो अभी यहाँ पे फॉरवर्ड बायस हो गया, तो व्हाट विल हैपन टू दीज मेजॉरिटी चार्ज कैरियर्स, व्हाट विल हैपन टू देम? विल दे स्टे हियर और विल दे बी गोइंग इनटू द बेस? ऑल ऑफ देम विल बी गोइंग इनटू द बेस, है ना? why this is happening? Because emitter base junction is forward biased, this junction is reverse biased. So again, holes, if they come into n type base, what will they be, majority charge carriers or minority charge carriers?
Minority charge carriers.
They will be
Minority.
minority charge carriers, है ना? n type
Yes,
है ना
sir.
बेस, तो यहाँ पे ये होल्स हो गए minority charge carriers. what they see here, they see a reverse bias, and we already know what happens. Reverse bias will aid the flow
Mi-
of
Flow of minority charge
minority
carriers.
charge carriers, so they will cross over here like this, just like what electrons did in the previous instance. There will be some recombination, and so not all holes starting from emitter will be coming into the collector. Again, as I said, for example, 100 holes are going from emitter into base, only 95 will reach the collector. I'm just giving you a figure for understanding purpose. समझ में आया?
Yes, sir.
Okay. ठीक है. Now let us see the various transistor currents. ये बहुत इंपॉर्टेंट था आज का, सबसे इंपॉर्टेंट कॉन्सेप्ट था आज का. Now we will see the transistor currents in detail. Okay, is there any doubt, any difficulty so far?
No, sir.
Very good. Okay. Okay, now we'll have to draw this again. Doesn't matter. Okay. So we have the N, we have the P, and we have the N. And we are connecting it like this. थोड़ा चेंज यहाँ पे हो रहा है, वो क्या है देखो जरा. So if I mark the currents in a conventional way, NPN में ये फॉरवर्ड बायस है, तो ये प्लस है, ये माइनस है, ये प्लस है, ये माइनस है, इसको बोलो VEE, इसको बोलो VCC. ठीक है. So how will the current flow in the external circuit be denoted? How will it be shown? देखो इलेक्ट्रॉन्स इस सिचुएशन में ये NPN है, उसको मैंने ये बेस एमिटर बेस जंक्शन को फॉरवर्ड बायस कर दिया and I've reverse biased the collector base junction. So this is what we have seen. तो इलेक्ट्रॉन्स यहाँ से यहाँ पे जा रहे हैं और यहाँ पे जाके कलेक्ट हो रहे हैं. Of course, we have already seen this. So इलेक्ट्रॉन का डायरेक्शन देखो फ्लो का. So कन्वेंशनल करंट फ्लो कैसे होगा? कन्वेंशनल करंट फ्लो कैसे होगा?
उल्टा.
उल्टा होगा. करेक्ट. तो इस यहां से करंट फ्लो होगा ऐसे ऐसे ऐसे. तो इसको बोलते हैं कलेक्टर करंट, बिकॉज दिस इज फ्लोइंग इनटू द कलेक्टर. यहां से जो करंट बाहर आ रहा है इसको बोलेंगे एमिटर करंट, और ये बेस है तो इसको बोलेंगे बेस करंट. इज दिस पिक्चर क्लियर?
Yes, sir.
In a similar way, I can show the current directions in PNP device also. So ये है P, N and P. इसको हम क्या करेंगे? इसको फॉरवर्ड बायस करेंगे. फॉरवर्ड बायस करेंगे और इसको क्या करेंगे? रिवर्स बायस करना है. तो यहाँ पे हो गया. This is positive, this is negative, this is negative, this is positive. This also is called as VEE. This is called as VCC. अभी करंट फ्लो कैसे होगा? डायरेक्शन yes, tell me. This will be the emitter current. This will be the collector current, and this will be the base current direction. So understand the difference between the conventional current flow and the current flow which was shown earlier. So if I now describe it in terms of the symbols, it will look like this. तो ये हो गया एमिटर करंट, ये हो गया कलेक्टर करंट, और ये हो गया बेस करंट. Similarly, ये हो गया एमिटर करंट, दिस इज द बेस करंट, दिस इज द कलेक्टर. Have you understood this? Hello? Hello?
So, sir, I have a doubt in PNP transistor.
Hello?
In PNP transistor, the direction of flow of minority charge carriers is from left to right, and the current direction is also from left to right, right?
Correct.
But in NPN transistor, the flow of in NPN transistor, the direction of flow of current is opposite.
You miss one thing. You are
But, sir-
missing one thing. Holes flow नहीं होते कभी.
Okay, sir.
समझ लो, holes flow नहीं होते. Holes क्या होता है? Hole क्या होता है?
Hole is a vacant place for electrons. I mean,
Yes, it is a placeholder for electrons. तो एक्चुअली क्या फ्लो होता है?
electrons flow होते हैं, sir.
Exactly. समझ में आया?
Yes, sir.
तो इलेक्ट्रॉन्स कहाँ पे आ रहे? यहाँ पे आ रहे. इलेक्ट्रॉन्स यहाँ पे आ रहे, यहाँ पे आ रहे. सो करंट फ्लो कैसा डायरेक्शन? कन्वेंशनल.
Left to right.
समझे ना?
Yes, sir.
अभी समझे?
Yes, sir. समझ गया.
Or in other words, you can also remember it this way that ये जो होल का फ्लो डायरेक्शन है वही कन्वेंशनल फ्लो करंट फ्लो है का डायरेक्शन है ना? तो
Yes,
there won't
sir.
be any confusion at all. समझ में आया?
Yes, sir.
ओके. तो और कुछ किसी को डिफिकल्टी है? If not, we'll go to the last topic for today, and that is the current components, which again is a very, very important concept. Let me just find out the figure. तो हम लोग क्या करेंगे? We'll take PNP device, which is a little bit easier to understand because the current flow direction is one and the same as that of a conventional. तो एक PNP डिवाइस लिया. Let me copy that. Okay, is this figure visible to all of you?
Yes, sir.
ओके. तो उसमें करंट कंपोनेंट्स कौन कौन से ये देख लेते हैं. ठीक है ना? तो earlier I had only said that there was only this whole current or the current which was composed completely of whole current. तो ऐसे तो नहीं होता है. Why? Why is that so?
Some minority carriers also.
माइनॉरिटी चार्ज कैरियर्स भी होते हैं. सो माइनॉरिटी चार्ज कैरियर्स यहाँ पे कौन से होंगे? पी टाइप में
Electrons.
होंगे. तो
Electrons.
इलेक्ट्रॉन्स के फ्लो के वजह से भी सम करंट इज कंट्रीब्यूटेड. एज यू कैन सी, ये ब्लू जो है ना करंट, ब्लू लाइन जो दिखाई दे रहा है, दैट इज द करंट कंपोनेंट ड्यू टू इलेक्ट्रॉन. होल करंट तो है ही पता आपने. दिस इज व्हाट वी हैव सीन. So as you can see, the whole current is much higher than the electron current. ये बात समझ लो. तो जो भी कंपोनेंट है उसको बोलते हैं I. The current component because of holes in emitter region. So this is the emitter region, this is the base region, and this is the collector region. So emitter region में the current contribution due to holes is called as IPE. I mean, we are just giving it some name. Okay. Similarly, INE. INE का मतलब क्या होता है? It is the current which is because of the electrons. और ये कौन से रीजन में? एमिटर रीजन. ठीक है. In collector region also, we have a similar kind of nomenclature. Okay, what is that? IPC and this is different here, ICBO. ये देखो ये क्या है, ये डिफरेंस है कंपोनेंट में. तो दिस इज द होल, दिस इज ड्यू टू होल्स, और ये बहुत इंपॉर्टेंट कंपोनेंट है. वो क्या है, ये क्या कंपोनेंट है, क्या हो सकता है? देखो, बेस कलेक्टर जंक्शन इज व्हाट, रिवर्स बायस और फॉरवर्ड बायस. बेस कलेक्टर जंक्शन और कलेक्टर बेस जंक्शन इज फॉरवर्ड बायस और रिवर्स बायस. कौन सा है? हेलो,
Reverse biased.
रिवर्स बायस. तो रिवर्स बायस में वी हैव ऑलरेडी सीन दैट देयर वाज समथिंग इन पीएन जंक्शन डायोड. रिवर्स बायस में क्या हो रहा था? पीएन जंक्शन डायोड में रिवर्स बायस हुआ था, तब क्या, वाज देयर एनी करंट फ्लोइंग?
Yes, sir.
व्हाट वाज दैट कॉल्ड एज?
Sir, saturation current.
रिवर्स सैचुरेशन करंट. अगर हम ये उसका देख लेते हैं तो ऐसे था ना, this was voltage, this was current, and this was the reverse saturation current. Of course it was a very small value, isn't it?
Yes,
In
sir.
picoamperes. You solved a problem based on this in your exam, है ना? हाँ या ना?
Yes, sir.
तो situation is very similar here. तो ये रिवर्स सैचुरेशन करंट ही है. Why? Because base collector junction or collector base junction is essentially reverse bias. Since it is reverse bias, you are going to have a reverse saturation current flow also. तो ये देख लो, बाहर एक्सटर्नल में IE है, एमिटर करंट यहाँ, कलेक्टर करंट flowing out, base current flowing out like this. Okay, and these are the internal current components. Very very important. ठीक है ना?
Yes, sir.
तो टोटल करंट अगर मुझे फाइंड आउट करना है, फॉर एग्जांपल IC, तो ये IC क्या होगा? इट विल बी IPC प्लस व्हाट? अभी डायरेक्शन भी देखो इसका क्या है, कैसा है, इन द सेम डायरेक्शन ऑब्वियसली. तो इट विल बी IC प्लस व्हाट विल बी द टोटल कलेक्टर करंट?
Sir, ICBO.
ICBO. ये बहुत इंपॉर्टेंट है, वेरी वेरी इंपॉर्टेंट. अगर एक्सटर्नल सर्किट में हम अगर देखते हैं यूजिंग द सिंबल्स, तो इट विल बी समथिंग लाइक दिस. If I reverse bias this junction, कलेक्टर करंट जो फ्लो हो रहा है, that is your ICBO. लेकिन यहां पे एक इंपॉर्टेंट चीज देखो, क्या है फर्क? दिस इज ओपन. So what is the definition of ICBO? What is the definition of ICBO? Why it is called as ICBO in the first place? ICBO means the reverse saturation current flowing between through collector base junction when emitter is open circuit. ये इसका मतलब होता है. तो अगर मैं यहाँ पे if I don't apply any bias over here, still then if I apply a reverse bias to this particular junction, obviously it will work as a reverse bias diode, PN junction diode, and current तो flow होना ही है. So this whatever current, collector current here, whatever it is, will be completely composed of ICBO because there is no current flowing from here. यहां से कोई करंट आ ही नहीं रहा है. तो जो भी करंट है इस सिचुएशन में विल बी ICBO ओनली. समझ में आया गाइस? Hello.
Yes, sir.
So why this O is there? It is the reverse saturation current flowing through collector base junction when emitter is open circuited. And there is no voltage applied to the emitter at all. ठीक है?
सर बट हम तो फॉरवर्ड बायस कर रहे हैं ना एमिटर रीजन को.
अरे फॉरवर्ड बायस करने के बाद your collector current will be composed of, it will have this component also. लेकिन अगर मैं फॉरवर्ड बायस नहीं करता हूं बेस एमिटर जंक्शन को तो ये कंपोनेंट तो जीरो हो जाएगा ना.
यस सर.
So what will be IC then in that case?
यस सर, रिवर्स करंट.
Only ICBO.
यस
समझ में आया?
यस सर.
Okay.
Yes, sir.
Okay. So I think it is enough for today. Later on we will subsequent sessions we will discuss about the next things. Important thing over here you have to understand is the collector components. Then we'll see some parameters associated with these current components. Okay. For example, the emitter efficiency. Then we'll see the transport factor. Then there is something called as large signal current gain, and so on and so forth. So I don't want to overload you with the same with more concepts today itself. So we will stop over here. If anyone has got any difficulty, please raise your doubts. Yes. तो अभी क्या करना है? Hello. How do
Yes,
you revise the concept? जो मैंने बोला है वो I hope you have written down some things.
Yes, sir.
These are very, very important things. Those people who are not paying attention, they are going to be in a lot of mess. Because transistor, bipolar junction transistor, is the foundation of electronics and telecommunication. I am trying to simplify it for you so that you will be able to understand the concepts clearly. ठीक है? So I'll stop recording now.